So we're going to talk today, section 1.8. I know it says 1.5 on here, but it's 1. I have different notes that I pulled from different places. Combination of functions is the first thing we're going to talk about. Then we're going to talk about composition. All right, you'll see the difference in a second. But when we talk about combinations of functions, we're adding them together, we're subtracting them, we're multiplying them, we're dividing them. All right, you're just going to get a bunch of different functions, a bunch of different equations, and they're going to say find the sum, find the difference, find the products, find the quotient. It can be written two ways, right? I can write a problem for you that says f plus g of x. That means to do what with the f function and the g function? What does the sign in the middle there mean? Add them, right? You're combining like terms. Or you can write it separately where it says f of x plus g of x. Same thing with the difference. If you're subtracting them, it can be written together where it says f minus g, or it can be written separately where it says f function minus the g. You guys see what I'm talking about? Okay? When you are asked to find the sum of two functions, all right, I understand that this says something. I'm going to write this differently. There's two different ways that questions will be asked. They'll be asked in terms of x, where that means leave your answer in terms of x, or they'll be asked in terms of a number. So in this case, this first question says f plus g of x. I'm going to rewrite it right here. So f plus g of x. I'm going to write another question over here that says f plus g of 2. One problem, your answer should have x's in it. The other problem should turn out to be one single number. Which do you think is going to have the x in it, and which do you think is going to be the single number? The one with the x is going to have the x's in it. The one with the number is going to have the number. So on this left-hand side, all they're asking you to do is take the f function, so I'm going to write it, 2x plus 1, and then the g function, which is x squared plus 2x minus 1, and then want them combined. You are literally combining like terms. I cannot impress upon you enough, guys, how to stay organized. Last period, people were all over the place because, well, oh, I forgot a negative sign. Well, their answer went from positive 49 and it should have been negative 7, all because we just forgot a negative sign. So it's really important that you keep yourself organized. But if we're combining like terms, write your answer in standard form. If I'm combining like terms, what's the first term I'm going to write down here? X squared, right? I have 1x squared. Then what? 4. Yep, I have a 2x here and a 2x here, so it's plus 4x. And then I have a positive 1 and a negative 1. What happens? They cancel out. So there is your composition, f plus g of x. That's what your answer should look like. Your answer is in terms of x. Does everyone understand? Now, another type of question that you're going to be asked is f plus g of 2. So instead of keeping your answer in terms of x, they want you to plug in 2. You can do this two ways. You can combine the two functions like we just did right here. Get x squared plus 4x, and then plug in the 2. Or you can plug in the 2 from the beginning. Some of you are going to, depend upon how you want to do it, it's fine. But if I have this, is my problem. X squared plus 2x minus 1. My personal suggestion is to combine the two functions first, then substitute the number in that they want to. Some of you want to go ahead and just say, oh, well, I'm just going to put the 2 in to both of them and then just combine. It's not a bad idea when you have lots of plus signs and you're plugging in a positive number. But when you are plugging in a negative number and you're subtracting functions, there's lots of negatives all over the place. I think it can get very confusing. So my suggestion would be, that's what I'm saying, you can do this either way. My suggestion would be to combine this first, which we already did over here and got x squared plus 4x, right? And then plug in 2, because they asked me here to plug in the number 2. So when you do that, you have 2 squared plus 4 times 2. What's 2 squared? 4. plus 8 is 12. All right, now if we went and just went ahead with this, where you guys didn't combine the function first, you would have gotten the same answer. But again, it's a little messier because you have 4, right? Plus 1 is 5. And then 2 squared is 4, plus 4 is 8, minus 1 is 7. 5 plus 7 is 12. You would have gotten the same thing, but you'll see in a second when we start subtracting and stuff, it can get really hairy. So my suggestion to you is to first perform whatever they're telling you to do, add, subtract, multiply, divide, then plug the number in that they give you. Yes, ma'am? All right, look at the subtraction one. Let's just say they had this. My answer should be what kind of an answer? A number. Why is it a number? Because there's no x. They're telling me plug in, evaluate this when negative 3 is all of the x values. So instead, you can, if you write out what's my f function, 2x plus 1 minus x squared plus 2x minus 1. Now some of you, so some of you are going to say, well, I don't want to combine it first. So watch. This to me is very confusing to look at. To say 2 times negative 3 plus 1 minus negative 3 squared plus 2 times negative 3 minus 1. And then get all of your negatives and all that stuff handled correctly. That to me is confusing. I personally think you should first combine the two functions. If I have a negative sign in between two parentheses, what do I have to do with that negative sign?
Distribute.
I have to distribute this first. So I would combine them to be one function and then evaluate with the number they give you. So I have 2x plus 1 minus x squared minus 2x plus 1, correct? Yes?
Yeah.
Okay, so let's rewrite in standard form. Negative x squared. I have a positive 2x and a negative 2x. Gives me what? Cancels out. Then I have plus 2. Is this much easier to evaluate than this? It just makes sense if you guys combine them first and then evaluate. So if this question said f minus g of x, this would be your answer. But I gave you a question and I said, okay, evaluate this when it's negative 3. So from this step, you would say, okay, I have negative 3 squared plus 2. What's my answer here?
Negative 7.
Okay, so I have negative 9 plus 2 gives me negative 7. But I'm telling you, the pre-calc part of this is not going to be your issue. It's when you have minus a negative, you guys are going to forget that it becomes a positive. Like little basic computations is what's going to give us a little bit of issue. That make sense? We okay? All right, let's look at this. What are they asking me to do here? Multiply. Do you see how f and g are stuck next to each other? So literally, guys, your f function is x squared times your g function is x minus 3. I want my answer to be in terms of x. So you distribute, and I get x cubed, what?
Minus 3x squared.
Minus 3x squared. Now over here, when they tell you to evaluate when x is 4, what that question, these are two different questions. This is a question saying f times g of 4. So again, I'm going to show you there's two different ways you can look at this. Some people are going to want to combine first. Some are going to want to just evaluate straight away. So I have x squared times x minus 3. All right, I'll show you the two ways. I personally, like I said, I think you should combine first. X cubed, negative 3x, and then substitute in the number they told us to, 4, right? So this is 4 cubed minus 3 times 4. What's 4 cubed?
64.
64.
Wouldn't it be negative 3x squared?
Oh, yeah, I forgot to square it. I'm sorry. So 64. And then I have 16 times negative 3 is 48. So my answer here is what? 16. If you don't do that, if you choose to just evaluate from the get-go, that is fine. You'd have x squared times x minus 3, right?
Yeah.
So you have 4 squared times 4 minus 3. What's 4 squared?
16.
16 times 1 is
16.
same thing. You can arrive at the same answer. I just think it's better, it's cleaner if you combine the two functions first, is all I'm saying. It's my opinion. Depending upon how your question is written, f minus g of x or f minus g of 2. You should have variables in your answer here. And you should have a numeric answer here. Does that make sense?
Yeah.
Okay.
Is there gonna be
Okay, we're going to talk about division here for a second. We're going to get into domain restrictions and stuff a little more tomorrow. I don't want to throw too much at you at one time. But division, right? If this says f divided by g, if I put my f function on top, square root of x, over my g function, 4 minus x squared. There's nothing else I can do to simplify this. But when they talk about domain restrictions, what does that mean?
And the denominator can't equal 0.
Yeah, the denominator can't be 0, right? So what we're going to do, we'll talk about this more tomorrow. Again, I just want to kind of touch on everything. We have to figure out where our denominator would be 0 or doesn't exist. So we're going to have to go through that. We'll talk about it more tomorrow. Some of you are just going to, this makes more sense to some than others. So I just kind of want you to see everything today, and we'll let it marinate for a minute. But you're going to have domain restrictions only when we have division, because your denominator can't be what? 0. Okay, we'll talk more about that tomorrow, I promise. Now we're going to talk about composition of functions. Instead of combining here, we're actually going to physically take one function and plug it into the other one. All right, you'll see the notation is different, so you should understand, you'll be able to differentiate between one from the other. This is how compositions of functions are written.
It's like substitution.
Yeah, it's just like substitution. That does not say fog. It does not say f times g. Do you see how the dot is open? It's an open circle. It's either going to be written f of g of x or g of f. Another way to write it is like this, where it says f times g of x, that sort of a thing. That's what it looks like. I understand that. This is the biggest takeaway I can give you from this. Work from the inside out. Work from the inside out. I cannot impress upon you enough how important it is to be organized when you do this, so you keep your thoughts straight, you keep your line of sight straight. All right? These are what the questions look like. We'll worry about the evaluate when x is 0 and x is 1 in a second. But A and B are two different questions. One is saying f of g of x, the other one is saying f of x. This is, I promise you, it's not as daunting as it seems. How did I tell you guys need to work? From the inside out. What is closest to the x in letter A, the f or the g? So you literally are going to take the entire g function and plug it in to the f. This is how you guys should, at least from the beginning, start to attack these problems. F of x is x plus 2. G of x is 4 minus x squared. Right? All I did was rewrite the two functions they told me. So, taking the g function, I'm going to circle the whole g function, and I'm plugging it in right there into the f function. You're just substituting. That's it. So I'm going to replace the x with what? 4 minus x squared. And then I rewrite the rest of the f function. So what goes at the end? Plus 2. Do you have any like terms to combine? Yes. Positive 4 and a positive 2 is what? So f of g of x is negative x squared plus 6. That's it. That's all you have to do. You take one function and plug it into the other one. Notice how this is in terms of what? X. That means I should have what in my answer? X. Now, if I told you, okay, evaluate this now, this composition of functions when x is 0 and when x is 1. Okay, so fine. Negative 0 squared plus 6. What's negative 0 squared? 0. So my answer would be 6.
You're asking what?
It says right here to evaluate when x is 0 or 1.
Oh.
So now if I plug in 1, I have negative 1 squared plus 6. Well, what's 1 squared? 1 times that negative gives me negative 1 plus 6. So my answer is what?
Oh, 5.
No, because I'm plugging in positive 1.
Yeah, but isn't
Yeah, but negative 1 squared.
No, that says negative x squared. If it was inside the parenthesis, yes. If you were plugging in a negative 1 and squaring it, but since there's no parenthesis telling you to include it, that negative's on the outside.
Then it's negative 1 plus 6.
Correct. You square the number first, then multiply it by the negative. We're going to practice. That's a good question. How do you know which to plug into? Well, where did I tell you to work? From where to where? From the inside out. So tell yourself, what are you going to do? You're going to take the f function and do what? Plug it into the g. So remind yourself the f function is x minus 2, or x plus 2, right? And the g, 4 minus x squared. So keep yourself organized. Circle, draw yourself a picture. Who cares? Take the f function, and I'm plugging it in right there just for the x. Nothing else is changing in that g function. I'm just replacing the x with the value x plus 2. So rewrite it. You have 4 minus, instead of x, what are we plugging in? X plus 2, good. And then it's squared, right? That right there, guys, pre-calc. Everything else, algebra 1. Where do you think you're going to have issues? Algebra 1. We forget our basic algebra skills a lot. But a lot of your pre-calc stuff, especially here at the beginning, the first step is your pre-calc, and then it's all based upon stuff that we have prior knowledge of. So we just have to make sure we stay on top of our algebra skills. What does x plus 2 quantity squared mean? We have to FOIL. It means I have 2 of those parentheses. So I'm going to rewrite my 4 and my negative. Leave that alone. We'll deal with that at the end. But I have x plus 2 times x plus 2. So we'll FOIL. Keep your 4 minus out in front. What's x times x? X squared. X times 2 is?
2x.
Good, 2x. Then I have 2 times x is? 2x. 2 times 2 is 4. Can I combine anything? Yep. I still have my 4 minus out in front. X squared plus 4x plus 4. Why am I making such a big deal of that 4 minus being out in front?
Because the negative needs to be distributed.
That negative, you have to do what with it? Through the whole
Distribute
front.
it.
Yes. If you forget that one little step, guys, what happens to your problem? The whole thing is wrong. So we have to make sure we stay on top of things. I'm going to distribute this negative here, here, and here. So I have 4 minus x squared minus 4x minus 4. They do. Very good. The 4's cancel out. So your final answer is negative x squared minus 4x. That is your composition, g of f of x. Now, if I wanted g of f of whatever, then we're going to plug numbers in. Yeah, we can plug in 1 and 0. What happens when I plug in 0? 0. We like those. What happens when I plug in 1?
It would be
When what?
We're going to go back and forth between, is it -5 or 3? Well, let's follow our rules. It says -1 squared minus 4 times 1. I cannot impress upon you enough, guys. When you plug numbers in, put them in parentheses. It makes you see things better. That negative is not inside the parentheses, it's on the outside. So that says 1 squared is 1 times that negative, so I get -1 minus 4 gives me -5. All right, this isn't actually on your notes. I just want you guys to write this down. Yes, sir.
I don't know. How would you know, like?
Can you go to B again?
Sure. Okay, write this down, guys. We'll keep these two functions. F of x is x plus 2, and g of x is 4 minus x squared. Yeah, write this down. I'm making up a new problem. What about if you had g of f of -3? Now you can do this two ways. You can take the f function, plug it into the g, combine it all, and then use -3. Or you can work where?
Since that just has one x, can't we just
Where did I tell you guys to work? Yes, where did I tell you guys to work? From the inside.
Ow.
From the inside out. So first of all, guys, plug in -3 into the f function. Then whatever you get, plug that answer into the g. These ones are a little easier than the other ones because you're just taking one function. So I'm going to find out first what f of -3 is. So -3 plus 2 gives me -1. Now I'm going to take that and plug it in right there. So 4 minus -1 squared.
3.
4 minus, what's -1 squared? 1. So my answer would be 3. But if you can just follow the rule of work from the inside, where? Out. Whatever is closest. If it said f of g of 3, put the 3 in the g, -3 into g, and then plug that answer into f. Work from the inside out.
example 7?
Okay, this finding the domain. Again, we're going to talk about domain tomorrow, but you have domain restrictions, guys, when you have denominators and when you have square roots. Why do you have a domain restriction when you have a square root?
Because it can't be a negative.
Can't take the square root of a negative number. So that would be an issue that we'll talk about. But if you had to find f of g of x, what are they asking you to do here? Take what? Take the g function and plug it in where? Into the f. So it would look like this. You would take, instead of x, you have, okay, I got the square root of 9 minus x squared, right? And it's squared minus 9. Take your time. You take that whole thing and you plug it into the x value. So you have the square root of 9 minus x squared. And you square that. What happens when you square a square root? It cancels out. So then you have 9 minus x squared minus 9. What happens to the 9s? They cancel, so your answer here would just be what? Negative x squared. And then we would talk about domain restrictions because you can't take the square root of a negative number. And we'll get more to that tomorrow, I promise. But what I want you guys now to do, pull up your practice. We'll talk about when f of g and g of f are the same because we're going to get into inverses. But pull up your practice. I want you guys to look at that for a minute.